Thank you for coming to my presentation. Today, I would like to talk about what is IoT and also like to make an introduction of myself. I plan to finish my talk in 40 minutes and will deal with these four topics in this order. First, I will make a self-introduction, then present a definition of IoT, examples of IoT applications, and finally introduce an example of IoT curriculum and training materials. After high school, I entered a university and was engaged in theoretical physics. So I was far from engineering at that time. But one engineering topic interested me was computer and its programming. After finishing a doctoral course of physics, I changed my subject to large-scale numerical simulations using supercomputers, which was still in the field of physics, but I moved toward to engineering thereafter. After spending some time as a postdoctoral fellow, I fortunately got a permanent position at the University of Yamanashi, which is located 120 kilometers west from Tokyo and at the foot of Mount Fuji. This is a picture of the campus. The summit of Mount Fuji you can see here. In the later years of my teaching career, I began stratosphere balloon experiments. I omit the reason and the background of that here. It just happened. Stratosphere balloons are gum balloons like this, filled with helium gas, ascend in the air, finally reaching about 30 kilometers in altitude. The picture in the right side was taken at about 24 kilometers in altitude. In spite that it is taken under the daylight, you see the sky is completely black. This is due to the diluteness of the air at this altitude. The air pressure is only a few percent of that at sea level. I pursued the experiment many times and mostly succeeded, which means I recovered the payloads and data without any troubles. However, high-altitude balloon experiments in Japan have inherent difficulties. In Japan, lands are narrow in width and mostly covered with forest, and there live many people in plains. So I came to Mongolia, which has vast land with less forest and less people. The picture on the right with Mr. Sergey was taken in 2016 when I came to Mongolia for the first time. The left picture is a typical trajectory of a balloon released at Ulaanbaatar. Though the wind direction and its speed varies from time to time, in this case the balloon flies more than 200 kilometers to the west. Here is Baganu and here is Jalgat. Balloons fly very fast typically, and it takes only 2 or 3 hours to land. My mission in the experiment was to recover the payloads safely and quickly. To achieve the mission, I have to predict the landing point as precisely as possible in advance, and have to track the real position of the balloon in real time. To track the position of the balloon, I developed a tracking device which has long-distance communication ability. The device was required to be lightweighted and was expected to consume less power to reduce the weight of battery. This is my first work on electronic circuit or IoT device. This was made up by just connecting components, a lithium battery, a step-up regulator, a- an Arduino controller, a GPS receiver, a LoRa communication module, an SD card logger, an environmental sensor, and a beeper. It was simple but worked great. Receiver systems were also developed. This is a work of one of my students controlling the direction of directional antenna. This picture was taken at Erdene, at the moment a world Guinness record. The highest altitude smartphone live stream was certified. The record was 30 kilometers plus. I took part in this project as an engineer. I applied my experience in the high altitude balloon to other systems like weather sensing. This is a self-powered weather sensor which is independent of power grid and send data via LoRa to a gateway where the data are relayed to the internet. By this system, we can collect rich environmental data in a cost-effective manner. That is my self-introduction or compressed personal history. I'm not an expert of IoT. I enjoyed myself in various projects at various positions of various fields. I came here hoping that I encourage you to find something new at which you enjoy yourself. IoT is an ambiguous word which is hard to define clearly. There are many aspects in IoT, and the viewpoints are different from person to person. Forgive me that my viewpoint is also biased. Let me start by asking you a question. IoT is Internet of Things. Then, of what was the Internet before IoT? Internet of what? One answer to the question is that it's the Internet of computers. IoT connects things which had not been considered as computers, such as phones, TV sets, cars, etc. In other words, we can say those non-computers became computers. That is my favorite definition of IoT. IoT is computerization of non-computers. IoT implies computerization of everything and creation of new types of computers. Smartphones are computerized phone. Do you remember? It was phone. Maybe younger people don't understand why this is called phone. Though many people don't categorize a smartphone as an IoT device, I'd like to define it as a typical IoT device. TV sets have been computerized for years. My little nephews use TV set, but they seldom watch broadcast TV programs, but they watch YouTube movies using the TV set all the time. Some of recent TV sets have none of tuners or radio receivers. That is nothing but a computer without a keyboard. Though I don't know whether Mongolian people need car navigation systems or not, almost all Japanese depend on it to visit unfamiliar places. Every car, even in the lowest grade, have been equipped a navigation system. However, recent cars sold in Japan are no longer equipped with it. Can you guess why? AI controlled? No, not so advanced. They still have a display in the dashboard, but don't have a dedicated navigation system. Instead, they just have USB connectors through which they can communicate with smartphones. Cars now can navigate the driver using a navigation system in the smartphone. Data and software can be updated more timely and more flexibly than before. This is another type of computerization of cars. If we define IoT as computerization of things, we naturally find that it covers the following two concepts: ubiquitous computing and embedded systems. Ubiquitous computing is implied that there are computers everywhere. Computerization of things is implemented as an embedded system. In IoT systems, computers are deployed everywhere, collect data, and communicate each other. Data are accumulated and analyzed. Models are built, and forecasts will be made if necessary. It acts on the real world by controlling machines and humans. I think IoT is an application-oriented paradigm. It isn't bound to specific technologies. In developing and deploying an IoT system, it is important to understand the essence of issues we are facing. Next, I would like to introduce some examples of IoT. Of course, there are countless number of instances of them, and we'll cover only tiny fraction of them. Let me start by looking near around us. Yes, this is a computerized gate. I don't know how exactly it works, but I saw this type of gates at many places in the city. They seem working in some coordination. Do they have a unified fee collection system? Does it work in citywide? How many years ago it was deployed? In Japan, we also have automatic fee collection system in parking lots, but they are all independent and a lack of flexibility and of convenience. This system is good application of IoT. This is another one you all are familiar with. The Autobus application provides users useful information including the position of the user themselves, autobus lines, and current autobus positions. The flexible fare collection system is also an application of IoT. Perhaps you are not so thankful to these systems. For a foreigner like me, it is so valuable. I have not tried this yet. Have you? Is this system working well? Even if something are going wrong, there must be many possibilities to overcome the issues and to improve the system using IoT. Last weekend, I went to Bogdhan Mountain and found it. One of the horses wore color with a GPS and a satellite transmitter. The rancher can monitor position and movement of their livestock. This is an example of IoT unique to Mongols. This is the final example and is that in construction industry. Komatsu is one of outstanding manufacturers of construction machinery and is also known to be a pioneer in IoT. This video introduces their recent solutions. We have come to the final section. I will present my tentative proposal for a new training program specialized in IoT. Here is my proposal for the goal of the IoT education program. As you see, it is a rather abstract statement. I would like to emphasize here again, IoT program should be application conscious. By the way, in the student pre-final presentation 2 weeks ago, I saw that the current graduation project of the electrical engineering course are application-oriented. Some of the themes are actually IoT related. Perhaps the goal of current program and that of my proposal are not so different from each other. The following are knowledge, skills, and mindset that the students of the program are expected to learn. Device design and implementation, computer networks, data analysis, AI and forecast, actuator control, and human-machine interfaces. Finally, insight into the essence of the problem, applied problem-solving skills, and willingness to try new things that allow the students to learn. This table represents a tentative curriculum for 5 years program in Kosen. My emphasis is not on lectures, but on the lab activities. Of course, lectures are necessary, but they should not be separated from lab activities. Lectures and lab activities should be mixed or interleaved. Students are expected to try themselves in timely manner what they learn in the lectures. The exception is this engineer ethics. I don't know how to teach ethics in practice. To utilize human resources and to reduce teachers' burden, joint classes with other programs are encouraged. Many classes can be run in cooperation with the robotics program, and some can be done with AI program. This final slide presents a list of video materials I made so far. They are intended to be referred by teachers, but some of the students will find them useful. Though overall presentations are in Japanese, you can use the automatic translation function of YouTube. Texts are mainly written in English. I will keep making these kind of short videos continually, hoping that by seeing them you figure out what IoT is and that you develop your own teaching materials on IoT. In this playlist, I will add useful videos by third parties as well as my own materials. That's all. Thank you again for your participation.